Today, we're diving into something that's, well, it's kind of part chemistry, part detective work. It's all about keeping our most important machines running, and it all starts with a blood test for your engine.
You know that feeling, right? That weird noise starts, the check engine light pops on, and then boom, a sudden and usually very expensive breakdown. But what if your engine could actually tell you it was getting sick, like weeks or even months before it all goes wrong?
See, with any complex piece of machinery, the real problems, they almost always start silently, deep inside where you'd never see them. And the cost of that hidden wear and tear can be absolutely massive. I mean, we're talking about tiny, tiny particles of metal, totally invisible, that are basically sending up a flare, signaling a slow breakdown that ends in a very sudden and very expensive catastrophe. And this is where that whole blood test idea really clicks. Think about it. The oil flowing through your engine isn't just there for lubrication. No, it's constantly moving, picking up and carrying tiny bits of evidence from every single part it touches. So if we can analyze that oil, it's like we're getting a complete health report straight from the heart of the machine.
Okay, so how do we actually do this blood test? Well, like any good detective, you can't just wing it. You need a solid, reliable rulebook. And for oil analysis, that rulebook is called ASTM D5185. This logo here belongs to ASTM International. They're a global organization, and their whole job is to create these technical standards. So their standard, this D5185, is basically the official procedure. It's the playbook that labs all around the world follow to make sure they get accurate, reliable results every single time. And that word, standard, is so important. It means that the way the test is done in a lab in Ohio is the exact same way it's done in a lab in Tokyo. That consistency is what gives us data we can actually trust, data we can use to make really critical decisions about maintenance. All right, now for the cool part. Let's step into the lab. This is where things get a little bit science fiction, because we're going to go inside the machine that makes this whole thing possible, the plasma spectrometer. You know, the goal here is actually beautifully simple. You take one single drop of oil, you turn it into light, and then you read its unique chemical signature. Because here's the trick. Every single element, iron, copper, aluminum, you name it, it glows with its own unique color, its own spectrum when you superheat it. So we can read that light, just like a barcode, to see exactly what's hiding in that oil. So the whole process breaks down into about 4 main steps. First, they dilute the oil sample a bit so it flows nice and easy. Second, they add what's called an internal standard. That's just a reference element to make sure all the measurements are super accurate. Third, and this is the really wild part, that solution gets fed into a superheated plasma discharge. And finally, the instrument analyzes the light that comes out, reading the unique signature from every single metal element inside. And when I say superheated, I am not kidding. We're talking over 6,000 degrees Celsius. That is literally hotter than the surface of the sun. It's that insane temperature that's needed to just vaporize the oil sample instantly and force every element inside to reveal itself through light. Okay, so the lab sends back a report. It's basically a list of elements and how much of each was found. Now the real detective work begins. What do all these metallic clues actually mean? Because every single metal in that report, it tells a story. It's a clue, a breadcrumb, that leads us right back to a very specific part of the engine. Think of this table as our detective's cheat sheet. So if you see a spike in iron, well, that points to where on the really big stuff, like the engine blocks, cylinders, or the crankshaft. What about copper? That tells us to check the bushings and bearings. Aluminum usually comes from pistons or the oil pump. But silicon? Oh, silicon is the real smoking gun. Because you see, silicon is basically dirt, sand. And if it's in your oil, it means dirt is getting past a bad air filter and is just grinding away at your engine from the inside. And it goes beyond just tracking wear and tear. For example, if the test picks up sodium or potassium, that's a huge red flag for a coolant leak into the engine. The analysis can even measure the additives in the oil, like calcium and zinc, which can tell you if you're even using the right kind of oil in the first place. So you've got all this data. How does a technician take this sheet of numbers and turn it into an actual, real-world diagnosis? Well, it's all about looking for trends. In a healthy engine, you'll see really low and stable levels of wear metals over time. It's just normal. But the alarm bells start ringing when you see a sudden spike.
That sharp jump in iron and copper you see here, that's the engine screaming that something has started to go wrong, and it gives you a crucial window to fix it before it's catastrophic. And this, right here, is why this is such a game changer. With this data, you're not just reacting to problems anymore. You're moving to proactive, predictive maintenance. You can predict failures before they happen, pinpoint the exact source of the problem, schedule maintenance when it's convenient for you, and the big one, you can make incredibly expensive machinery last so much longer. And you know, the real power of this whole technique is that it's not some niche thing. It's trusted and used everywhere, all thanks to that idea of international standards we talked about.
I mean, just look at the global reach. On the left, you've got ASTM International from the US. On the right, the Turkish Standards Institution, the TSE. They both have standards for oil analysis, and they're built on the exact same foundation. This global agreement is what ensures the results are reliable, whether you're running a factory in America or managing a shipping fleet in Turkey. So that dark, used oil you drain from your car, it's not just waste. It's a liquid diary. It's a detailed record of everything that's been happening deep inside your engine. Which kind of leaves you with one final question, doesn't it? The next time you change your oil, what secrets might it be holding?